Hi, this is Jack Downs. I'm doing a lesson, an online lesson for you for this Friday's class because I can't be here. However, we should cover all the same material. You might be tempted, especially on a Friday, to skip over this lesson, but it's extremely important, and this stuff will be on the quiz that's coming up. So let's get started. As usual, we should start by going to Moodle, and I've gone to our daily schedule. I'm looking at today's class. The topic is, what is sound? I asked you to bring your drive and headphones daily, but we won't really need them today. But really, soon we will need them, like next class. You were to have read Podcast Solutions Chapter 1, which is a reading that was handed out in class. This is an example of the reading guidance I give. In other words, these are the questions I could ask you on the quiz. I might ask you, I won't ask them all, but I might ask you these questions. And I will ask you something from the reading on the quiz. There they are. By the way, there is a quiz coming up on Wednesday. Yeah, Wednesday. So, due next class. Audacity manual exercise. That'll be handed out to you. It's also, I'll explain it later on in this lesson. Must have flash drive, must be labeled. I will have either already given you labels or you'll get your labels today from Gina. So you just sort of attach the label to your drive and be able to show us the drive next class. And it says quiz coming Wednesday. There it is, an audio video definitions and what is sound. That's what we're going to do right now today. And then there's another reading handout, still not from the textbook, Journalism Next, Chapter 7. I'm asking you to read it by Monday. And this, by the way, would be the questions could be asked on the quiz about Journalism Next. There it is. Then you would see Monday and Wednesday. What does it say about the quiz? There it is. Quiz today. Oh, there's a description of the quiz. Rule of audio definitions. We did those the other day. What is sound? Doing it now. Audacity manual exercise. That's the exercise you're going to do following today's lesson. And overview of digital audio. First two reading assignments. And you can use an index card on the quiz. This will be explained to you in person too. Okay, that's the end of the schedule. You should be up to date there. And of course, you can review it on your own and ask Gina for help too. So let's continue. I have a presentation called What is Sound? Some of this will first start to seem extremely elementary, but it'll get harder soon. So let's get started. This presentation, by the way, in PDF form is available on Moodle. What is sound? Sound is vibrations transmitted through a medium, usually air, that becomes sound when detected by a microphone or a listener. In other words, this definition answers the age-old question, if a tree falls in the forest and nobody was there to hear it, did it make a sound? No. Somebody has to be there to hear it. We need to have sound. Sound has to be vibrations that are detected. Otherwise, it doesn't become sound. It's just vibrations. It's just energy. It has to be detected by a microphone or a listener. What is noise? Unwanted sound. Okay, that makes sense. What is a wavelength? Oh my goodness, wavelength? What's going on here? All right, well, let's back up a second. Let me show you some things. So we got this vibration going through, boom, 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 boom. Vibration moving through a medium. What's the medium? The medium is air. Let me show you an example. Right here. Okay, good. And I'll make that a little bigger for you. Let's see if I can. Okay, good. So imagine that this is where the sound, the energy is starting from, right? I'm going to push on play. And what happens is, boom, energy goes out. Boom, energy goes out. Each time this vibration is moved through the medium. The medium might be air. In this case, it's red dots. Or imagine I was pushing on a row of students. I push the first student, who pushes into the next student, who pushes into the next student. Well, that would be a vibration, my energy that I pushed on the first student, moving through a medium of students through a row in a classroom. Get the idea? Of course, sound is not like one-dimensional like that, just like along one line and just one way, right? In fact, let me try to find it. Waves actually spread out more. Now imagine that this is the center point it's coming from, and so what actually happens is it also is going out as it goes. It's going out as it goes too. I think that, so you get the idea there. So that's how it works. Three-dimensionally. Now imagine that one-dimensional little line we saw before with the finger. Now we're looking at it from like straight ahead, and we're seeing the whole thing go out. And now I'm going to play this. And is it going to work? Ba-doom, ba-doom, and it's just showing us again. Same idea. Okay, so that's the idea of these waves. The waves are the energy that's passing through the thing. And in fact, we'll close this up. You could also say the waves. Let's look at it like this. Make this bigger. If the waves are these pulses of energy going through the air, then that energy, the high and the lows of it, are represented by a written wave, like that. And waves have a wavelength. The wavelength is the distance from the tip of one wave to the tip of the next. Now, usually I do this presentation with a whiteboard or blackboard or something, but now I'm going to have to use a paint program. And I'm pretty terrible at this, so please bear with me. Okay, so let's imagine that we have an axis, right? And what are these things? This axis, this is the amplitude. I'll make an A here, which is the size of the amount of energy. That's what's up and down. That's the size of the wave. And this axis over here is time. Time as it goes along. I'll put a T there for time. Okay, so now let me go ahead and draw a waveform. Okay, goes up, it comes down, comes up, comes down. A nice simple wave. Well, you might ask, if that's the energy pulsation and another pulsation, well, what is the wavelength? Well, the wavelength would be this distance. The distance from one point on a wave to the next identical point on the wave. And then we usually think about wavelengths as the distance from the peak of the wave to the next peak. But it would work out the same if we did from the valley to the valley or so on and so forth. It's the same distance, and that is the wavelength. I'll put a W there so you can see wavelength. Okay, let's go back to the presentation and not my silly drawing. So wavelength is the distance between any point on a wave and the equivalent point on the next wave. We usually think of it as from the peak to the peak. Good. Well, why do you care about that? You'll understand that in just a minute. What is the amplitude? The amplitude is the strength or power of a wave signal, the height of the wave when viewed as on a graph. It corresponds to volume, our perception of wave amplitude. Oh, okay, all of a sudden we have a term that makes sense, a volume. How loud is the wave? The bigger the waveform, the higher the amplitude, the greater the volume. So when you see a wave and it's really big, it's really loud. When you see a wave and it's really small, it's really quiet. Okay, good. And again, I did show you that, right? That is the amplitude, the height of the wave. And we call this axis the amplitude axis, which is like the amount of energy. So let me go ahead and grab one here. So this would be a much lower amplitude wave, and so on. And of course, a bigger one would be higher amplitude, and amplitude is volume. Good. So what comes next? What is frequency? Oh my goodness, frequency. Frequency is the number of times the wavelength occurs in 1 second. We call this cycles per second. We also call it hertz. There is an all-purpose unit of measurement called hertz, which is numbers of something that happens per second. So we can call it cycles per second, CPS, or we could call it hertz, which is how many times it happens per second. And the more times it happens per second, the higher the frequency is, and therefore the higher the pitch is. And the fewer times it happens per second, in other words, the slower the wave, the lower the frequency, and the lower the pitch. What is pitch? It's how high, how low the sound is. So the higher the frequency, the higher the pitch, and the higher the sound is. And likewise for lower. So let's look at that in my little chart here. My little chart. And let's go ahead and just make a new one because it's getting too messy. Okay, here we go. I like the black, right? Here's my axis, my next axis right there. Good. And now we've got, of course, this is amplitude here, amplitude. You're going to have to be able to make a little chart like this, and time. Hopefully you will write the word amplitude and the word time instead of just the letter A and the letter T, though. But I can't write with this program. Okay, so here we go. I made a wave for you before, okay, right? So here's a nice, this would be a nice smooth wave like that. Good. Okay, so let's think about frequency. So let's change to a different color. Now, what is a high frequency wave going to look like? It might have roughly the same amplitude, but it would be a lot more wavelengths in every second. So there would be it'd be going faster. So this green wave has a much higher frequency. There's more wavelengths, more of this distance per second, as opposed to the red wave, which is only like 1. Where's the second marker? Well, we're just imagining that time is going. It's kind of a little abstract here. And then to make this really messy, let's change to a different color, like yellow. And what about this wave? What if it just barely gets going and it just starts to go down and we can't even see one wavelength there? That would be a really low frequency. Low. So the green one would be really high and the yellow one would be really low. And the red one would be somewhere in the middle. Okay, let's keep on going. So that's frequency. We need to know that because of pitch. Pitch and volume, which is amplitude and frequency. Okay, so, well, how much amplitude is normal, or how much do we want? Amplitude is measured in decibels, which are written as dB, as they are right here. That's in dB. Decibels is a somewhat unusual unit because it isn't really, I mean, it does correspond to something in reality, but it's really our perception of it. So it's how loud it seems. So it's really a bit of a subjective measurement. But we have a scale and we use it. And it's important to use because we have to be careful not to be exposed to sounds that are too loud for too long. So 0, in this case, doesn't mean zero sound, really, unable to be detected by any instrument. No, it just means that's the normal threshold of hearing, which can change a lot from person to person, really. And then a whisper is about 30, around 30. Normal conversations, 50 to 65. A lawnmower gets up towards 90. Above 90 for prolonged exposure over a long period of time can cause damage. Then we have a train or a farm tractor. Now that's up 100 or above in that range, around 100. That means only 15 minutes could cause damage. And then we have a power saw, which is getting up to 110, a jackhammer, really loud construction sounds. Now we're talking about 1 minute. Just being exposed to that for 1 minute without any protection could cause damage to your ears. And then 125, 130, like if you're at a super loud rock concert and right in front of the giant speakers, that can cause pain. That's very bad. Even a short amount of time, very short amount of time, could cause permanent damage to your ears. So that's some ideas, and you should have a general idea about what's normal conversation, for instance. What's something that would cause pain? Okay, frequency or pitch is measured in cycles, which is wavelengths per second, or hertz, which could be capital H or lowercase h. So 1 CPS equals 1 Hz. 1 cycle per second equals 1 hertz. We often use kilohertz, which is kHz, which means 1,000 hertz is frequently a measure we use. The faster the sound source vibrates, the higher the frequency. And the higher the hertz, the higher the CPS, same thing, right? So we were talking about amplitude a moment ago. Well, what are the frequencies? Okay, the frequencies of human hearing are quite wide-ranging, although we lose it a lot as we age. 20 hertz, really low, to 20,000 hertz, extremely high. 20,000 hertz, see, that's the same thing as 20 kilohertz, right? We lose the ability to hear this range as we age, especially at the high end. Human voice range is about 80 hertz to about 1.1 kilohertz. In other words, the average range of our voice that we can make any sound is less than the amount we can hear. We can hear much higher than the sound we can really make with our voice, even in a screeching, high-pitched scream. But our average speaking frequency is even more restricted. We only speak over a very small amount of frequencies. The average adult male, 85 to 155. Adult female, 165 to 255. So you should have a general idea about the range of our hearing and frequency and the range of our speech and frequency. Okay, just took a little break there and back. This is where we were. No, this isn't where we were. We were here. Yes, frequency and talking about the pitch and the cycles per seconds or hertz, and then the frequency range of hearing and of speaking and of our voice. Sure, we were talking about frequency, but first we were talking about amplitude and therefore decibels or volume. And I forgot to show you a couple websites I wanted to show you. Just to say I did, let's go ahead and do that. This is a website called, here's the one I want. This is there's a lot of websites that represent what different things, how loud they are. This is doing it with a dial here. Actually, if you use this, I'm having some trouble with the sound here, but it would actually try to play a sound, but it's not really that useful because you can just change this level of the output from your computer, so it doesn't really mean that's how loud it is. But the dial is right. For instance, a siren going by could be 110 to 130, extremely loud, especially if you're standing right there. So you'd want to get away from that sound or not be around that sound for more than an extremely brief period of time. If it's just driving by, that's okay, but if you're around a siren a lot, you'd want to protect your ears. And other types of like conversation. These numbers are not always the same as on every site, but that's a good idea. For instance, lawnmower, or what about a karaoke? That could be pretty loud, watch out. What about a jet ski? Not quite as loud. But anyway, consider ear protection for that range. Lots of good sites out there that give you an idea about the activities you might be engaged in and how loud is it. Is it too loud? Do you need to protect your ears? Likewise, we were talking about frequency, therefore pitch. So the issue is, what are different pitches? So I'm going to play this. It's a little bit loud there. See, look, watch the hertz as they go down and down. It gets very low. And then if I go up, 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 they get annoyingly high, and so on. And you can actually choose different musical notes here, which have the cycles per second or the hertz attached there also. So we'll stop that. So this online tone generator, the links to these things are at the end of the presentation, should you want to use them. You can get the presentation, of course, in a PDF on Moodle. So, okay, the next thing I want to talk about is the sample rate and sample format. These are the main things that determine the quality of a digital recording. So far, everything we talked about relates to the actual sound, the sound wave, and how we can draw it. And some of the things that are involved, like amplitude and frequency and how they relate, wavelength and so on, right? Okay, but how does that sound wave get into our digital recording? Well, in an old-fashioned analog recording, like an old-fashioned LP, the whole sound wave was copied with one quality or another into that vinyl. But in digital recording, the entire wave is not copied. What's copied are little samples. It's what is the condition of that wave at that moment the sample is taken. So let's use my little paint program here to draw what I mean. So if I draw, again, an axis, when you should know by now, and you should be able to draw these between amplitude, which I'll put here, which you would write out, and time, right? Good. And I'll draw the waveform. There it goes, right? And continues, right? So the issue is, what if we just take a sample here and a sample here? In other words, at this moment in time, take another sample. We've got our digital recording, goes and finds where that waveform is at that moment. Well, this would be a really jerky, rough recording because there's not that many samples. But in reality, we use a huge number of samples, 44,000 samples a second. It's CD quality. So there's so many that it becomes almost a 100% true representation of that waveform, because there's so many samples all over it at every moment saying this is where the wave is now, this is where the wave is now, this is where the wave is now, and continuing and so on. You get the idea, right? So that sample rate, the rate at which the samples are captured, is measured in hertz again, which is something per second, samples per second in this case, but it's still hertz. An audio CD has a sample rate of 44,100 hertz. Or you could say 44.1 kilohertz, or often as a shorthand we just write 44 kilohertz. So 44,000 samples every second. This is the default sample rate that Audacity uses because audio CDs are so prevalent. So we will be using this rate. There are higher and lower rates. The higher the rate, of course, the bigger the file size. The other issue is how good are each of those samples. That's the sample format, which is also called sample size and also called bit depth. You can see different things. Essentially, This is the number of digits, the amount of computer information in each of these samples. An audio CD has a precision, has a sample format of 16 bits, which is our default. There are lower numbers like 8, and higher numbers like 32 or 64. They tend to go by 8s. Again, how much information goes in that sample, in addition to how good the sample is, determines the quality and the file size. More sample rate, bigger sample format equals bigger files and bigger quality, so it's always a trade-off between quality and size. Okay, so now let me show you how this relates to our digital editing tool, which is Audacity. I have Audacity open already. My computer looks a little different than yours probably. This is Windows 10, but anyway, it's the same icon. It's a little kind of a like a headphones on a kind of a zigzaggy yellow and orange thing, and you can find that on your desktop in the labs. And of course, you can download your own copy, as I mentioned. I've opened or imported an audio file. Well, what is this audio file? Let's take a listen and see. It's some music. Good, okay. Well, so far you say, well, that's interesting, but it looks like a big blobby thing here. I don't see any waveform. How you keep talking about waves, but I don't see any wave. Well, let's zoom in a little bit. I'm just going to select a little bit of that, and I'm going to fit the selection. Okay, so I took that little tiny bit, and now I zoomed into it. Well, it's starting to look a little bit like a wave, but it's still very fuzzy. It doesn't really look like a wave to me. Well, let's just take a little bit again, and let's zoom in again. All right. All of a sudden, we are zoomed into the thousandths of a second. This is 25 seconds and 0.030 seconds, and so on. So we're zoomed in extremely close here. And all of a sudden, we start to see we do have a waveform. However, it isn't that simple, pure sine wave kind of a waveform. There's a lot more character to it because it's music, because it's something that's complicated. So all of those samples are there, and there's a lot of up and down and changes and so on because it's a complicated information. And this is what a real waveform looks like in nature, in a way. Well, no, not in nature. In our digital representation of nature. And this is where when we zoom in, we can see there really is a waveform, even for something as complicated as music. Okay, that's the end of the lecture part of this. Now let's look back at the daily schedule. And just a reminder, as I said before, what's due next class is something called the Audacity Manual Exercise. I'm going to go over that right now. Must have flash drive, must be labeled. No, I'm not going to start deducting points yet or anything, but you should be given the labels on Friday, and if you don't get one, I'll give them to you on Monday. And you do want to have your drive labeled, and we're going to do an exercise with your drives on Monday. So please, you got to bring your drive on Monday. Please do. And there's a quiz coming Wednesday, as I mentioned, and there's more about that down below. So you can start to prepare for that. And you can use an index card, handwritten, both sides, index card, regular size, as supplied by me. And then there's reading, which you were already given, which is due by Monday. But what about this exercise? Well, you should either have it, be given it in class on Friday, or else you can find it in our folder. It's called the Audacity Manual Exercise. There it is. And this is what it looks like. And it is due on Monday. So here's the point. You've got three choices. You can use Audacity in a classroom or the lab to do this. Or you can go install your own copy of Audacity, as is explained in the Moodle front and some links there. Or you can actually just view the manual online and get it that way by not installing anything. Let's see, and here it is. Here's the manual. I just clicked on the link in that PDF. And you see this manual is pretty much the same, other than there might be some slight differences in version, but it will work the same for this exercise as if I have Audacity up. And where's Audacity? Here it is, right? And I go to Help, and I go to Manual. That's going to open the manual again. Jeez, it's like the same thing. Yeah, so in other words, you can view the manual through the program by, as I just did there, going to Help and Manual. Or you can go to that link, and you can do this in your own copy of Audacity or whatever. So there's different ways to get to the manual, but to get to the manual one way or the other, there you are. You have the manual. And we have, that's not what I wanted. I lost my copy of the manual exercise now. Great. I think so. Let's bring it back up again. There it is. Okay. So as I was saying, so one way or another, you get that manual in front of you, and that's all explained in this top part. And once you do, I want you to read these sections and plenty of any other sections you wish to. Under the reference link on the left, go to the digital audio link, review this page thoroughly, and so on. This is linked another way to get to it, but the reference on the link on the left, reference digital audio. And there's all this stuff here, digital sampling, digital audio quality, sample rates, sample formats. Hey, some of this has to do with what I just talked to you about. Size, clipping, that's an important thing. Compressed audio, lossless compression. All this is worth discussing and reading. Okay, so you can look at that section. Good. Okay, what else? There it is. Okay, then, oh, I forgot to mention, yeah, and the reference link and so on now. Now review the Guide to Audacity project window diagram. Where is that? Well, that would have been something we saw in the beginning, actually. I'm going to go back. This is the guide to the project window. All this stuff here, which has got all these labels of what they are. All these things are labeled. It's what the screen looks like in different parts of the screen. There's questions about that you need to know. You need to be able to answer. And what else? Then it says, review the following sections. Audacity Foundations, managing, importing, exporting, playing, and recording. You'll find that stuff under Audacity, using Audacity Foundations. Hold on just a second. Oh, sorry, here it is. Under using Audacity, Audacity Foundations. All these links in here. Now, I'm not saying you have to go through all these. I gave you a list of them in the assignment. So, okay, good, more on back. Editing with Audacity is also down in that same area. You're going to go check on that. Okay. Editing with Audacity, this section here, right? Good, good. Okay, so you're going to go over that. Also in the FAQ, under Installation, Startup, and Plugins, review the answer to the question, how do I download and install the lame MP3 encoder? So that's in the FAQ section and the same in the manual also. So you can go there. So you're going to go check out that. Here I am in the frequently asked questions. I'm going to click on it. And then actually, you know, your instructions say something about it being number 10, but it's here as number 4. How do I download and install the lame MP3 encoder? Under Installation Startup, it's right there. So you'll find it there. Frequently asked questions, which was one of those other links right there. Good, okay. So you do that. And of course, feel free to review other sections of the manual and try out the tutorials. You may also want to view the glossary. The more you learn about Audacity now, the better you'll do in our projects. That's true. Now, having done all that, or as you answer these questions through those different places, I want you to answer these questions. How are you going to answer these questions? You're actually going to type this up in a sheet to hand in class, next class. Well, that'd be Monday's class. What is a waveform? Give me the answer from the manual, or in your own words from the manual, whatever, and numbers, so on and so forth. So answer these 10 questions, and that's what gets handed in. Take some more time, perhaps, to go over some of the tutorials that would help you out. And if you want some files to use, there's some files you can download from those some of the first resource folders have some MP3 files. Those are audio files. You can use those. And then finally, there's a section here about installing Audacity, which is similar to the section that's on the Moodle page itself about installing Audacity, and a warning there about don't click on the ads. Okay, that should do it. I hope that this online lesson worked for you. So you got to go do this homework and do that reading, and then prepare for class on Monday. See you then.